Now in this diagram, you can see that we start with the basic empty mass, which is the mass of aircraft and standard equipments inside it. When we add variable loads to the basic empty mass, we get DOM or dry operating mass. What are variable loads? The weight of pilot, crew baggage, food, water, other optional equipment, etc. So basic empty mass plus variable loads gives us dry operating mass. Now, there are two ways or there are two branches that originate from the dry operating mass, the left one and the right one. Now, the left side, when we add takeoff fuel or fuel on board to dry operating mass, we get operating mass. Okay, takeoff fuel is the fuel in your fuel tanks when your aircraft is on the runway ready for takeoff, right? And this takeoff fuel will not include taxi fuel, engine startup fuel, run-up fuel, etc. Okay, so this is your takeoff fuel, also known as fuel on board. Over here on the right side, DOM plus traffic load gives you zero fuel mass. Next, zero fuel mass plus fuel will give you takeoff mass. Now there is another way to find out takeoff mass, that is operating mass, which has fuel but not payload. So we add traffic load on the next step and then we get takeoff mass. The third way to get takeoff mass is this way. Dry operating mass plus useful load gives you takeoff mass. Now what is this useful load? This useful load is nothing but takeoff fuel plus traffic load. Okay, so useful load is nothing but takeoff fuel plus traffic load. Fine, so that gives you takeoff mass. Now here we have been asked to find out useful load. So what is useful load? Useful load is equal to traffic load plus takeoff fuel or fuel on board, right? So now in this question we have not been given traffic load and fuel on board separately. So there is another way to find out useful load, that is takeoff mass minus dry operating mass will give us useful load. Takeoff mass minus dry operating mass equals to useful load. Okay? So takeoff mass. What is takeoff mass here? It is this much, 302,550. Dry operating mass is 161,450. So that is equal to useful load. Therefore, useful load will be equal to 302,550 minus 161,450. That is equal to 141,100. Okay? So 141,100, option Charlie. Simple. Now here the information of fuel on board or takeoff fuel is irrelevant. Okay? Next. Question number 52. Total mass of this aircraft is 7,500 kg. Center of gravity location is 80.5. Aft CG limit is 79.5. How much cargo must be shifted from the aft cargo compartment at station number 150 to the forward cargo compartment at station number 30? Now the station means the position. Okay, in order to move the center of gravity location to the aft limit. So here is your aircraft. Fine, this is your aircraft, let's say. Now every aircraft will have its forward CG limit and an aft CG limit. So similarly, this aircraft has this forward center of gravity limit and the aft center of gravity limit. The aft center of gravity limit is 79.5. The actual CG location is 80.5, that is beyond this aft CG limit. So it's unsafe, right? So your center of gravity limit is 80.5. So in order to bring the CG location within the acceptable limits of forward CG limit and aft CG limit, we will have to move some cargo in the aft compartment okay, which is in the aft compartment, to some position or to a new position in the forward compartment. So from here we will have to move it somewhere here, let's say. Okay, so we have to find out the mass or the weight, how much weight we have to move from the aft position to the forward position. Now there is a formula for that. The formula is mass to move, mass to move equals to total mass of aircraft multiplied by center of gravity movement required. So in this case, we have to move our center of gravity from 80.5 inch to a new position, that is 79.5. So center of gravity movement required, the change required, okay, divide by distance, how much distance this mass has to be moved from here to here, the distance mass to be moved. Okay, next. So total mass of aircraft 7,500 multiplied by CG movement required. So 80.5 minus 79.5. So a change of 1 divide by distance the mass is to be moved. So you have to move this mass from 150 to a new position which is 30. So 150 minus 30 is 120. Now 7,500 divided by 120 is 62.5 kilograms. That means you will have to move or relocate a mass equal to 60.5 kilograms from the aft compartment to the forward compartment. Okay? So mass to move is equal to 62.5. Option alpha. Next. Question 53. Airplane's weighing schedule indicates that the empty mass or basic empty mass is 57,320 kg. The DOM is 60,120. Zero fuel mass 72,100. Which of the following is a correct statement? Okay. So we have been given basic empty mass, dry operating mass, and zero fuel mass. You get these three pieces of information we have been given. Option A, operational items have a mass of 2,800 kg and the maximum useful load is 14,780. Next is operational items have a mass of 2,800 kg. Traffic load for this airplane is 11,980. Operational items a mass of 2,800. Maximum traffic load is 14780. Now what is the value of basic empty mass? It is 57,320. Dry operating mass 60,120. Now the difference between them is your variable loads, right? So 60,120 minus 57,320 is 2,800. So this is nothing but your variable loads or operational items, also known as operational items, crew baggage, food, water, etc. Okay, so this is correct. So the first part of all these three statements is correct. The second part, useful load is 14780. Now what is the formula for useful load? Useful load is what? Useful load equals to, as we saw in this question, takeoff fuel plus traffic load is your useful load, right? Now in this question, we can calculate payload. Zero fuel mass minus dry operating mass is payload, okay? But we do not have the value of takeoff fuel or fuel on board. So it will be impossible to find out useful load without that piece of information. So eliminate option alpha. Now we are left with Bravo and Charlie. Traffic load. What is zero fuel mass? It is 72,100. Okay. So zero fuel mass minus dry operating mass. Zero fuel mass minus dry operating mass is traffic load or payload. So when you subtract that, when you do that subtraction, 72,100 minus 60,120, it's 11,980. So your traffic load is 11,980. So that is option Bravo. Okay, 11,980. Next, the crew of a transport airplane prepares a flight using this data. Block fuel. Block fuel means ram fuel. When your aircraft is positioned or parked at the ram, the all the fuel in its fuel tanks will be called ram fuel or block fuel. And this ram fuel will be inclusive of engine startup fuel, run-up fuel, taxi fuel, takeoff fuel. Takeoff fuel is nothing but your trip fuel, alternate fuel, reserve fuel, contingency fuel, right? So it's the total fuel at the beginning of your flight. Trip fuel, taxi fuel, maximum takeoff mass, maximum landing mass, zero fuel mass, DOM. What is the traffic load required? So step 1 that I always follow, make 3 columns, one for takeoff mass, the second for landing mass, and the third for zero fuel mass. Now in the takeoff mass column, you are going to write the value of maximum structural takeoff mass or performance limited takeoff mass, whatever is given in the question. If both these values are given in the question, you will write that value which is the lower than the other value. Okay. So over here we have only one value, that is 170. So write that here. In the landing mass column, you are going to write the maximum structural landing mass plus trip fuel, right? In order to find out takeoff mass. So that is another way to find out takeoff mass. Landing mass plus trip fuel. So 148.5. Fuel is 29,000. So 29. 148.5 plus 29. 177.5. So fuel mass, again, write the value plus fuel on board or takeoff fuel, right? So zero fuel mass is 112.5 plus fuel on board or takeoff fuel. Now takeoff fuel will be the fuel in your fuel tanks when your aircraft is on the runway. And this takeoff fuel will not include taxi fuel, run-up fuel, startup fuel, etc. So it's total fuel on board. Takeoff fuel is nothing but ramp fuel or block fuel. From that total fuel, you are going to subtract taxi fuel. So 40,000 minus 800, okay, 32,000, 39,200. So you are going to add this 39,200, so 39.2. 39.2 plus 112.5, 151.7. Okay. Now out of these three values, three takeoff values, 170, 177 decimal 5, 151 decimal 7, you are going to select that value which is the lowest. So 151.7 is the lowest of all. This becomes your regulated takeoff mass, 151 decimal 7. Step number 2, use the formula regulated takeoff mass equals to dry operating mass plus fuel on board takeoff fuel plus payload, traffic load. So payload will be equal to regulated takeoff mass minus DOM plus fuel on board. That is 151.7 minus 80.4 plus fuel on board 39.2. And 19, 32.1 or 32,100 kg. So option alpha, okay, 32,100 kg. Zero fuel mass and dry operating mass differ by the mass of usable fuel, differ by the value of traffic load, are the same value. So zero fuel mass and dry operating mass are separated by traffic load or payload, right? Traffic load is the joining link between DOM and zero fuel mass. So the correct answer is they differ by the value of traffic load mass. Very easy. 56. The following data applies to an airplane which is about to take off. Maximum takeoff mass and performance limited takeoff mass. Since one is structural limited takeoff mass and another is performance limited takeoff mass. DOM is given excluding crew hand baggage of 640, crew baggage in hold 110, fuel on board 60,700. Calculate the mass of the useful load. Okay, so useful load equals to takeoff fuel plus traffic load. Now in this question, we have takeoff fuel or fuel on board, yes, and plus traffic load or payload. But we do not have payload or traffic load in this question. So we cannot use this formula. So the remaining formula, useful load equals to TOM minus DOM, takeoff mass minus dry operating mass. Takeoff mass minus dry operating mass equals to useful load. What is the takeoff mass? Now you are going to see there are two takeoff mass values. You are going to select that value which is the lower one. So the lower value is 137,300. 137,300 minus dry operating mass. Now dry operating mass is 58,400 excluding crew and crew hand baggage and crew baggage in hold. Now you are going to add these two values to this dry operating mass given because dry operating mass is inclusive of crew baggage, food, water, other optional equipments, right? So if they haven't included these things in the DOM calculation, we have to do that. So our final dry operating mass will be the original 58,400 given in the question plus 650, 640 plus crew baggage in the hold 110. So 58,400 plus 640 plus 110 is 59,150 minus 59,150, that is equal to 78,150. Is option Charlie. Okay. Next. In relation to an airplane, the term basic empty mass includes the mass of airplane structure, complete with its power plant, systems, furnishings, other items of equipment considered to be integral or standard. Its value is printed in the loading manual and includes unusable fuel. Its value is found in the latest version of the weighing schedule as corrected to allow for modifications, is inclusive of allowance for crew baggage, other operating items. It is entered in the loading manifest. So first things first, option Charlie will be wrong because crew baggage, other operating equipments are not a part of basic empty mass. They are a part of dry operating mass, right? Next, it's so we are left with options Alpha and Bravo. Printed in the loading manual including unusable fuel. Now this part is right. Basic empty mass does include unusable fuel, oil, other fluids. Bravo is found in the latest version as corrected to allow for modifications. It's better to select option Bravo. It's the more proper one compared to Alpha. Okay, so always whenever there are modifications made in your aircraft, you need to update the basic empty mass again and again wherever there are modifications. So you will find the latest basic empty mass in the latest version of the weighing schedule as corrected to allow for modifications. Next. 58. Aircraft's basic empty mass is given. Maximum takeoff, landing, zero fuel mass are identical, 5,200. Ram fuel is given. Taxi fuel is given. What is payload? What is payload? So, payload is nothing but there are different ways to calculate payload. Takeoff mass minus operating mass is payload. Zero fuel mass minus dry operating mass is also payload. Okay. So the third way is, see, we have one formula: regulated takeoff mass equals to dry operating mass plus fuel on board plus payload. So in this equation we have payload and we have all the three values. Regulated takeoff mass is 5200. Dry operating mass is what? Uh, Dry operating mass is not given to us. Okay. So we cannot use this formula. The second formula which says zero fuel mass minus dry operating mass equals to payload. This formula can't also be used because we do not know dry operating mass. Okay, so we cannot use that. The third way is takeoff mass minus operating mass. So takeoff mass minus operating mass equals to payload, right? So takeoff mass is 5200. Operating mass, what is operating mass? It is DOM plus of fuel. So now in this question, we do not have dry operating mass. We do have basic empty mass. So what we can do is we can consider basic empty mass to be equal to dry operating mass because this aircraft seems to be a light aeroplane, right? So if we include that, if we consider that possibility, so basic empty mass to be equal to dry operating mass, okay? So DOM plus takeoff fuel. So 3000 plus takeoff fuel will be ramp fuel minus taxi fuel. 650 minus 50, that is 600. So 3600, right? So operating mass 3600 will give us a payload of 1600 kilograms. So option A. Okay, so this can be a possibility. Next. In relation to an airplane, the DOM is the total mass of airplane ready for a specific type of operation, excluding usable fuel and crew. So that is wrong. DOM does include crew, baggage, all that variable loads, but it does not include usable fuel. So first part is right, but the second part is wrong. Potable water, lavatory chemicals, yes. So DOM is nothing but variable loads plus basic empty mass. These variable loads are crew, baggage, water, food, chemicals. Usable fuel and traffic load, no. So statement bravo or option bravo is the right one. DOM is nothing but crew, baggage, water, food, etc. Traffic load and takeoff fuel are added after dry operating mass, not before it. Okay, so after. On an airplane without central fuel tank means fuel tanks located in the fuselage. Uh, the maximum zero fuel mass is related to what? Maximum structural takeoff mass, wing loaded trip fuel, bending moment at the wing root. So option Charlie. Okay, the maximum zero fuel mass means the mass of aircraft only with payload or only with traffic load. Okay, without any usable fuel. Usable fuel like reserve fuel, trip fuel, taxi fuel, etc. Okay, so all the load imposed by the payload or traffic load, which is fixed, which is going to be fixed as you take off from or as you fly from point A to point B. Okay, so the load imposed by all the constant forces in the fuselage of your aircraft uh, is governed by maximum zero fuel mass. Okay, there is a limit up to which you can load your aircraft or fill your aircraft with payload and traffic load. Because if you do it excessively or if you cross the maximum limit, there will be unbearable or excessive loads or stresses imposed on the wings of your aircraft. Finally, just remember the wings of your aircraft have the job to lift your aircraft in the atmosphere as well as to uh, hold the fuel in the fuel tanks, right? So there will be unbearable stresses imposed on the wing roots, and that can create a structural damage. Okay, if you cross the maximum zero fuel mass limit on any day. So remember the bending moment at the wing root. Okay. So we come to the end of this lecture. I hope you have understood all the 10 questions I have answered in this video lecture. Practice these questions again and again. Very simple questions. To understand how to solve these questions, you must first be aware and familiarized with or familiar with the basic flow chart, basic empty mass, DOM, operating mass, zero fuel mass, their definitions, how to find out one factor from another factor, etc. Okay, so practice is the key. All solve the questions from Keith Williams as well. I have already uploaded those lectures. So watch those lectures, practice, and automatically you will become very confident and in this confident in solving this questions. Best of luck.